So without further ado, will hand you over into the very capable hands of John Adeleke.
All right. Thank you, Helen. Thank you. And thank you, everybody, for attending. Industry profiting from a sustainable circular economy. That's a long title. And the idea of this is to, at the end of it, for everybody to think about what they do with their equipment when they're finished using it. In order to do that, we need to have a bit of context for this. And the context is with where our technology is at the moment. So, does everybody know what an amplifier is here? Yeah? Okay, great. And everyone knows what a PA system is here? Good. And how many of you are in the maintenance industry? Does anybody fix things here? No, right. Okay, and that's part of the reason we want to get to that. So, for me, over the last 30 years, I've seen the technology, or where we're going, have the most advances in electronics, and particularly in amplifiers. So, we're going to have a look at the differences between what was going on 30 years ago and what's going on now. And the context will become clear soon. When we look at a PA system, we look at mature technology, which is microphones and loudspeakers. There's very few advances in those. Basically, these are motors that receive longitudinal wavelengths and produce longitudinal wavelengths. So with the microphone, you shout into it, and the loudspeaker shouts back at you, if it's French. With that mature technology, that's changed over the years. So we've now got the loudspeakers hanging on their sides or in columns, and that's also based on mature technology around ribbon tweeters, even though the manufacturers might not want to say that, but that's what it is. So if we go back to our mature technology again, we can see that we need an engine. There's our engine, the amplifier. And it is the amplifier we're going to have a look at, because you can't produce any sound without an amplifier, regardless of how big the PA system is. I brought along with me an amplifier that was discontinued in the late 80s, or they're still selling these around the early 90s. And this amplifier weighs around 27 kilos, produces 600 watts per channel. What happened around the 90s, the early 90s, is that manufacturers started to have a look at the size and the weight and the efficiency of the amplifiers being made. And at the time, the components that are available allowed them to produce amplifiers that could range from between 600 watts and 1,000 watts per channel. But as you can see, that's limited because the components were not available. But also, you'll notice that these are all under 27 kilos. These are pretty cutting-edge products at the time when they came out. How have we achieved that? We can look at the class of the amplifiers. There's a thing we call topology. And the topology is the way that the amplifier's electronics are arranged to produce different types of efficiency, firstly, and different types of fidelity. I'm sure some of you know about this, so forgive me if you already know it. But the obvious class is a Class A amplifier. This amplifier produces the best fidelity, but has the worst efficiency. So Class A amplifier is what you probably would see with your hi-fi amplifiers in the early to late 70s and probably in the 80s. I'm not sure what they're doing now, but that's pretty much the best kind of fidelity you can get out of a transistor. The next class is Class B, but I haven't seen a commercially available Class B amplifier. What we do is we bias the amplifier so it produces a bit of Class A and has the efficiency of Class B. A Class B amplifier is a push-pull amplifier, so one half A way to look at it simply is that it's two Class A amplifiers with one amplifier doing a negative side of the signal and the other half doing the positive. That's the easy way to explain it. And also what we do is we have a bit of negative feedback to help get rid of that distortion, control the gain, and that sort of thing. The next class which you'll come across is Class D, and this is probably the most common amplifier you're going to see in the industry now. Class D has the worst fidelity, but the best efficiency. A Class D amplifier is going to get hot the moment you start putting signal through it, but it remains cold, and it's based on sampling. The D does not stand for digital. It's Class D because it was the next letter that came after C, which we haven't got as an audio amplifier here. Then we have Class G, or Class H, and this manufacturer was one of the, how can I put it, one of the pioneers behind Class H amplification. And with Class G, Class H amplifiers, they have multiple rails on them. The difference between Class H and Class G is the way that those rails are switched. An amplifier, with all the other amplifiers I've talked about, they work at full rail, so there's no switching. Whereas with the Class G amplifier or Class H amplifier, the rails are switched. So the amplifier, it's another way to gain efficiency. Why have the full rail going through the amplifier when it's needed? So it's signal dependent. One modulates and one switches. And then this is what I call a Class J amplifier, because the nearest we can get to it was a Class J amplifier, which was used for RF and also for microwave generation. And the idea behind this is that it's really a Class D amplifier with Class AB output. So you get the best of both worlds. You get the fidelity and you get the switching, the control. So the amplifier is not conducting unless the Class D part of it tells it to do so. That's it in a nutshell. Those are amplifier classes. And from that, we can also look at the power supplies as well. I forgot, I brought something along with me. Not sure, I'll show you that in a minute. But in addition to the amplifiers, the efficiency needs to be gained in the power supply as well. And the most common power supply that you will come across is what we call a biphase bridge or a linear power supply. That's what's in this amplifier, and that's what makes it so heavy. And those sorts of power supplies have very poor efficiency, so a lot of the energy is being wasted just sitting there doing nothing. And then we come on to switch mode power supply. So this is what we call a primary switching supply. So the mains is turned into DC and then chopped. And with the switch mode supplies, this is where I think the greatest advancements in amplifier technology has come about. With the switch mode supply, you can have power factor correction, and I'm sure you've all heard of that before. You can have power supplies that limit the amount of current an amplifier is going to draw based on its signal. And this is where amplifier technology really took off. To give you an idea of where we are in terms of the technology, I have with me a single channel from an amplifier. If you want to pass this around, this is 5 kilowatts. That's a 5 kilowatt output stage. And it's good to have that in your hand. That is basically almost 5 times the power of this amplifier here. Wrong. Wrong. Okay, so what's happened is we don't have many single channel, dual channel, or dual channel amplifiers. We've gone multi-channel. So we're now fitting, that particular amplifier has 4 of those in it. So we have a 20 kilowatt amplifier at the top there. To the bottom, that's another 4-channel amplifier made by KRA. And at the top, we have a 4-channel amplifier made by Acoustics, I believe. But that's where we are now with amplification. It's all gone multi-channel. There are even 32-channel amplifiers available, very high power with 32 channels in 2 rack spaces. So it's a rack space lower than that, and we've got 32 channels. I think with amplification, we've hit a sort of Moore's law for amplification. I don't think we can get any bigger. We can't squeeze any more into a 2U or 1U box. So the natural progression for that is to go to integrated loudspeakers. And I don't know when the first integrated loudspeaker came about, but an integrated loudspeaker is a loudspeaker that has its amplifier and speakers all in one. And I put that up for a bit of context because that is an integrated loudspeaker. You just plug in and plug and play. So where are we? Around 1998, a company came out with what I'd call probably the first serious integrated loudspeaker for public address, and that was Mayer Sound. And as you can see, this loudspeaker is 82 kilos, produces 620 watts, and has a very high output. This is cutting edge at the time it came out, but it's cumbersome by today's standards. It's 82 kilos. If we roll on forward to 2020, we have a loudspeaker, integrated loudspeaker that weighs 23 kilos, has a power output of 1100 watts, and produces 131 dB. This is the 1100 watt amplifier that powers that speaker. As you can see, it's pretty small. So in that amplifier, you've got the power supply, the high switching power supply, and the Class D output stage as well. And that's where we are now, pretty much. One of the companies that I've got a lot of admiration for is RCF, because we're here to talk about the circular economy. And one of the things we can look at is how we manufacture things, how we make things economical to manufacture. And one of those ways to do it is to make one thing and then turn it into another. And RCF do that with their, what they call a DigiPro amplifier, which I brought along with me. They use a single amplifier to do more than one job, and they program the DSP. Now, if you remember earlier, I talked about mature technology. There isn't really much change in the way a loudspeaker generates its sound. It still uses a cone driver. It still uses a horn in some instances, and you can arrange those in columns or anything else. But as a lot of you know now, a lot of corrections are done in what we call the frequency domain, particularly with finite impulse response filters. You can look that up on the internet to sort of explain how that works. But what it means is that with this amplifier module, they can take it, reduce the power just by programming it, and correct the EQ by adjusting the phase and the amplitude in that frequency domain. So this is quite a clever way of manufacturing, a very ecological way of manufacturing. And I'll hand that around as well. So some of you may have seen that before. Yeah. And so, yeah, that gets my green stamp of approval for the way that that's made. Okay, so in a nutshell, in conclusion, over the last 30 years, the most ecologically sound amplification or PA engine you're going to come across will have a combination of a Class D output stage and a switching power supply. Most of you will use an integrated loudspeaker, either for installation, live work, What else is there? And as you can see, this is Glastonbury some years back. They were integrated loudspeakers, Martin MLA system. So you will use these. One way or another, you will use an integrated loudspeaker. There are manufacturers who go against the grain and don't like the idea for obvious reasons or for good reasons. But those guys, if they're not going to use an integrated loudspeaker, they will definitely be using multi-channel amplifier. So that's where we are with the technology. Okay, so let's move on to our circular economy. The idea behind the circular economy is to make something when it breaks, make something, use it when it breaks, reuse it by fixing it or taking the bits out of it to make again. This is ideal, but I don't think we're there yet. I'm not even sure we're ever going to be there in my lifetime. But we want to avoid this. We don't want to take something, make it, use it, dispose of it, and then put it in landfill or burn it or chemically recycle it. The idea is that we want to start reusing things, think about what we're doing with those things. There are some standards that came out in the early 2000s that have changed over the years. One such initiative is what we call ROS. And the idea behind ROS is that these chemicals, particularly lead and mercury, are not used in the manufacture of equipment because these substances are harmful to people should they breathe them or if they're put in landfill. And that brings us on, or well, it dovetails us into the waste electrical and electronic disposal, the WE as we call it. And basically it's telling us that we can't bury things or we can't dispose of things that have 0.1 by homogeneous weight. And by that I mean everything that, if you look at something as a whole, 0.1 of that whole mustn't have any of those substances listed above if you're going to bury it or if you're going to put it in landfill. There is an exception, which is cadmium, which is 0.01. Now, the reason why a lot of these standards have changed is that the people creating the standards realize that there are certain things that can't be made without dangerous chemicals in them. So the mitigation is the WE. But this has changed, and this is just sort of like a précis of what those standards represent. But they are changing constantly. And now we're out of the EU, there has to be a UK equivalent for that as well. So, the pandemic effects on audio maintenance, because that's my background. I'm into audio maintenance. We've lost staff to other industries, such as logistics and IT, because people don't want to fix things anymore. There's a problem with spare parts from manufacturers because of the supply chain issues, which you've probably all heard of, things such as the chip shortage. In addition to that, we have long lead times. That's a screenshot from Farnell Electronics, and that's for a common chip. You always hear about things being made on these processes, 5 nanometer, 3 nanometer, 10 nanometer, for 18, we can't get hold of this. This is a common chip. This is a 555 timer. And you can see that's on a year or longer lead time. So this is a problem, and that problem's exacerbated, especially now with the problems we're having in Eastern Europe. So expect that to be worse. There are good things to come out of the pandemic. One of them is that responsible manufacturers are now starting to take end-of-line products and refurbish them and sell them as good as new. And this is a really good thing. I spoke to another manufacturer yesterday, loudspeaker manufacturer, who said that they're going to embark on a similar process to take end-of-line products, refurbish them, and sell them as new together with warranty. And I'm all for that. It's been done before. It's done around 2012 2013 by an amplifier manufacturer, but for some reason they stopped doing it, maybe because they didn't need to do it. But people are going to have to do this because you can't get the spare parts. If you ask any of the manufacturers here, they'll be telling you they're waiting probably 6 or 7 months for new amplifiers, so you can't get them anymore. So you have to use old ones. Okay, our problem is that 90% of the products found, or the ones that go 40, are less than 5 years old. And these end up in recycling. And the way around that is that you can fix these things, get them working again, or use 2 to make 1. But that is the problem. There are some things that we're trying to do, such as right to repair. The UK introduced laws last year around July, August, giving people the right to repair. Now, I don't know about all of you, but I've always been trying to repair my stuff over the years. I don't know if anybody recognizes these. These are Haynes manuals. So we've got a wonderful thing called the internet now. If you really want to take something apart and have a go at fixing it, you can. And this was an early internet that we had access to. Right to repair will address some of that, but the laws are already fought because the manufacturers have been given time to, in the case of these white goods, 2 years to come up with this information for end users to fix things. Right to repair isn't only about right to repair. Right to repair, at the end of the day, is about choice. It's about your ability to say where you want to take something to repair, or whether you want to have a go at it yourself. Most people don't want to repair things. They don't want to have a go. Even if you give them the instructions, as I pointed out here, when you mess it up, you take it to somebody who's going to do it. And it puts value on the product that you want repaired and the people that want to do the repairs for you. So it's not an argument anymore. Okay. There is a problem that we've got as an independent repair centre, and that's getting hold of spare parts. Manufacturers, some of them have this attitude to race to the bottom with parts, but we work on, all of you are installers, some of you installers, some of you run hire companies. You work on this thing called repair to value. So if the ratio of the repair comes in at around 50, 60%, you probably say, yeah, that's fine, let's go ahead with it. But once it goes over that part, you decide to throw it away. Hence the less than 5 years old products being found in skips or landfill or recycling centres, more to the point. So the parts are uneconomical. They make these parts uneconomical to replace. And I've brought along an example with me. And this is an example where the part that's obviously going to go wrong, which is this pot here, can't be replaced because the manufacturer will only replace the whole circuit board. I can pass this around if you want to have a look. Let me, guys at the back there. And this is a problem we face all the time, where we just want to replace a component. The manufacturer won't supply us that component, but the complete circuit board. So the rest of it goes in the bin. But there is a way around that. We start to reuse parts now more than ever. And in some cases, a manufacturer will ask you to completely replace the product. There is one manufacturer that I dealt with years ago that would only repair products that were in warranty. Once those products were out of warranty, the manufacturer wouldn't touch it. And this is something I've seen with quite a few pro audio companies, probably the ones that are making MI products. Okay, manufacturers need to do better. Something that's close to me is transducers. Talked about mature technology earlier. In order to make a woofer, you need to recone it. That's a recone kit. This is the part that goes inside the chassis. I've seen manufacturers provide woofers that have very odd impedances, sometimes 12 ohms, and we like to joke about the 13 ohm woofer. Nobody rates an amplifier into 13 ohms or 12 ohms. They rate it into 2, 4, 8 or 16 ohms. So why are manufacturers using 12 ohm drivers in very high quality transducers? What happens is when that speaker gets burnt out or it's blown, the manufacturer will tell you you need to buy a complete driver for maybe £1,200, whereas you can recone it for about £40, £50, and the recone kit is going to cost you, this is a baby one, but a recone kit's not going to cost you more than £200, maybe 250. And that's a problem. I've already told you the problem with the gain pots. They can use a potentiometer that's got a slightly better quality on the part that's going to be used all the time, but they don't, so that they can supply you. And also they can use metal can devices on the installation amplifiers. Although I talked about Stone Age technology and all the other things that are available, if you're going to make a Stone Age amplifier, use a Stone Age transistor. That's a metal can transistor. That transistor is very unlikely to go wrong, whereas this one will go wrong at some time and normally take out a bank of transistors. Then you're in that position where they're saying to you, well, buy a circuit board rather than just replace a single transistor. These transistors are still available. They're made under license in places such as India. And as you know, Motorola were one of the first companies to make these sort of bipolar devices. So this is a way forward. The weight doesn't matter in an installation amplifier because it's going to sit there. So why make it with plastic devices? So these are things they can do. You're welcome to have a look at these afterwards. Okay, this is the reality of where we are now. 12.5% of our products are recycled. So that leaves a lot left. A lot left that's either going to end up in landfill, or we're going to try and reuse it, or take the bits of it in the case of refurbishing those parts and getting them done again. The average lifespan of electrical products is 4 years. 880 megatons of CO2 in a European electronics manufacturer. And 10 years, assuming that right to repair comes to our industry. So that all points to one thing. It means that we should start reusing products again, because although in our ideal world we want manufacturers to supply products or spare parts for 10 years, it's not going to happen because some of them go bust. So these old bits that you're throwing away, you can keep them and use those parts for something else. This cost of repair, this is based on what we do at Ampman. That's our average price for repairing a professional audio product. That's around £1,800 or so. So it's worth repairing. Okay, there is another problem we've got in the industry. I call it brain drain. A lot of the good, experienced engineers aren't as young as me, and they're either about to retire or have retired. In fact, most of my engineers are at that sort of point in life. They don't need to do it for the money. They do it because they like bringing dead things to life, much the same like me. Electronics repair is not considered a seminal profession anymore. We're seen in the background. Whereas when I used to repair TVs, I was a hero because you only had 4 channels in those days. So, and 4 channels, 1 living room, my whole family to watch it. So if your TV broke, I'd come out and I'd fix it on site for you. So I was a hero then. Not anymore. As you know, the TV sets that are like 4 years old, you throw it away, you buy a new one. Go to Curry's, go to Dixon's, buy a new one. So we need to get more people involved with the repair of things again. The pay is not so good because if I say to somebody, I'm working at £80 an hour, they go, oh, why is it £80 an hour? But if I bring my BMW in to be repaired and it's nearly £200 an hour, nobody asks the question. And the way around that is to make things more expensive. There is a perception still, and I can show you some emails that we've received, that we're just mucking around. We're still at college playing with the PA system, not doing things seriously. We're just having a bit of a laugh. And also, the biggest thing I've seen is that when we left the EU, a lot of the young people that are interested in fixing things came from abroad. And that's not political, it's a fact. We don't have those young people wanting to do that. I can't compete with Amazon. That's the bottom line, or Tesco's. So that's our brain drain problem. And this has gone a bit quicker than I thought. All right. So, yeah. So, from my point of view, the future of audio maintenance, which is what we've sort of gone from where we started and to where we are now, is there will be strong legislation to stop people from throwing things away or just ending up in landfill. That's the expectation. The reality is there aren't enough people to police it. The only time they're going to make a big deal about it is if a very large organization does something wrong, and that justifies the time spent to police it, because you'll get a hefty fine or a penalty for getting rid of rubbish, or not rubbish, getting rid of good stuff in that way. The global supply problems will lead to reusing of products. Well, I've already indicated that's already happened, so that's a good thing. And then our expectation is we want younger people to take an interest in bringing dead things back to life again. There is hope. Because of the supply chain issues, products are going to start costing a lot more money. And if things cost a lot more money, it means that the cost of those repairs go up, and it also means that the remuneration for repairing goes up as well. And at the end of the day, the money talks. And if we can get that right, then we've got a future in bringing dead things back to life. That's it. Over.